And then the question is, what is it? What is petroleum? Petroleum is a mixture, like coal was a solid mixture. Petroleum is a liquid mixture. It's not a pure substance. It's a liquid mixture composed of thousands of compounds, and depending on where you're getting your petroleum from, the actual percentages of those compounds varies, but it is a liquid mixture. Okay, and of those thousands of compounds, most of them are hydrocarbons. Okay, there's thousands of different ways to arrange carbons and hydrogens. Oh, I said it right here. It's mostly hydrocarbons, and so what happens is the petroleum is removed from the ground, and it's easier. Well, it's harder to get to than coal, but it's easier to transport because you can just pump it through pipelines from place to place, and so in that regard, it's easier to manage. But then once you get it, like for example, coal. Most of the coal that we dig out of the ground is just put on trains, taken to the power plants, and just burned as is. Some of the lighter coals, the browner coals, are processed a little bit beforehand to get rid of some of the sulfur and other contaminants. But the hydrocarbons, or the petroleum, really needs to be processed before it's useful. And so it's normally either by tanker if it's coming from the ocean, or even from pipeline from the ocean sometimes, or pipeline from wherever its source is. It's piped to refineries, and at the refinery, the mixture is separated by physical process in a physical separation technique called distillation. So it's separated in refineries into fractions, and sometimes they say it undergoes fractionation, and that word fractionation or fractioning just means to separate it into different liquid mixtures based on the properties. Okay, so and the technique that's used to fractionate the petroleum is a technique called distillation. And distillation is a method of separating liquids based on the boiling point. Okay, the boiling points of the liquids. And as it turns out, in the liquid mixture that is petroleum, some of the compounds, the hydrocarbons vary in chain length from 1 carbon to 60 carbons in their molecule. And so the smaller ones have lower boiling points, and the bigger ones, the heavier hydrocarbons, have higher boiling points. So you can start boiling the liquid, and it's transitioning from a liquid to a gas, and then start cooling it across a tower, and the heavier things, because they have the higher boiling points, will liquefy, and you separate the liquid from the rest of the gas. That's the concept of distillation. So it's used a lot in chemistry to separate liquid mixtures. So if you say you have a heater source down here, you have some flame down here, and this is your distillation tank, and you've got the liquid in here, and it starts boiling, and then the gases go up a tower, and then you cool the tower. It's different temperatures, and so the heavier fractions will liquefy first and drip down into a collection container over here, and you'll collect the liquid here, and then you'll have a different temperature here. The lighter liquids will then liquefy and drop down there. So that's these different sections would be your different fractions. Okay, this is a fraction, say 1, say fraction 2, and you have many, many different fractions, and that's how you separate the liquid mixture. You have to, in order to have it, the liquid be useful, because there's different uses for different sizes of the hydrocarbons. So you guys, those of you who live near the coast, have probably seen an oil refinery before. This is an oil refinery, and this column right here is the distillation tower or distillation column. And so this is a schematic diagram of what it looks like on the outside, this big column. Okay, and so you have a place, the crude oil, petroleum is also called crude or crude oil. The petroleum is pumped into the boiler, petroleum, or crude oil. Let's get a bigger picture of this. I just want to show you, this is what it looks like from the outside. This is the schematic diagram. Let's look at a bigger picture of the schematic diagram. There we go, that's better. So the crude oil or the petroleum is pumped in, all right, and it's all mixed here in the boiler. And so the liquid boils, and then this is your distillation column. Some of it is really, it's just going to become kind of more viscous when you start boiling it. If it's not hot, it's almost like a solid, but it's going to settle to the bottom. The ones with the chain length are more than 20 carbons, and that's the asphalt. That's going to come off the bottom of the distillation column. And then you get to the next level, and those are going to be your industrial lubricants. And then the next layer up above that is going to be gasoline, jet fuel, diesel, LRG gasoline. LRG stands for liquefied refined gas. All right, that's going to come down. Then they're going to move up to the gasoline part. Then you're going to have diesel, jet fuel, gasoline, and LRG. LRG is liquefied refining gas. Liquefied refining gas. Let me see. Liquefied refining gas. Okay. See what it is the top C1 through C4. That's methane, ethane, propane, and butane. Those are all gases at room temperature and pressure. So when it's mixed in underground under a lot of pressure with the rest of petroleum, deep underground, it could exist as a liquid under a lot of pressure, and then then when it's brought above ground, it's going to, as soon as it's given the opportunity, it's going to separate from the liquid mixture. So it's going to go right to the top of the distillation column. It has the lowest boiling point, and it's a gas actually at room temperature and pressure. And then you get to the next fraction down, C5 through C12. That's the fraction where we find gasoline in this fraction, because the most common octane is what we call gasoline, but it's really a mixture. And then jet fuel is heavier, and then the diesel fuel is even heavier. It's oilier. If you've ever seen diesel fuel versus gasoline, it's an oilier liquid mixture. Now this business down here, gasoline, jet fuel, diesel, LRG gasoline, this is because what these heavier hydrocarbons, C15 through C18, really don't have a lot of commercial value as they are. So they are put into this situation called a cracker, and then they are changed into gasoline. I'll tell you details about how that works in a minute. So it's heavier. It comes off at a lower fraction, but then we do something to it to modify it, and then it's going to go up and join in with this fraction right here. Okay, so same with the gases. This LRG is where we've liquefied some of these gases. And reformer, that's another process where they take the hydrocarbons as they are and then chemically modify them in a process called reforming. So we'll come back to the reforming and the cracking in a minute, but for now I just want you to know that this is a physical separation technique based on boiling point. Get everything boiling, and then the lower the higher boiling points, when you start cooling it, they'll liquefy first, and then you separate them off. So they're called fractions. The process is called distillation, and it's a way to separate that very complicated liquid mixture.